to ask. So we're starting with today is 6-4 notes, and the main idea is now to describe what's happening to the slope and the y-intercept as you do some different things to the line. So we're going to move the line somehow. It's going to change the slope, it's going to change the y-intercept, and we're going to identify what's changing and how it changes, okay? So the first thing you have to know, a little bit of vocab, is what is a parent function? So the parent function is the most basic line. So it is the most basic line. And I'll tell you what that most basic line is just in a second. So the most basic line, it is actually y equals 1x plus 0. Y equals 1x plus 0. Now, a little shortened version of 1x plus 0, Bree, make sure you're writing this down, is y equals x. Y equals x. Do you see how I got from 1 equals, or y equals 1x plus 0 to y equals x? Okay, just shorten. You don't have to have the plus 0. You don't have to have the 1 in front of the x. Okay? That is the most basic function. Now, a family of functions is an equation that is somehow related to that family of or to that parent function, and it's how it's related. In other words, is the slope changed? Is the y-intercept? How does it change? So a family of function is just a related line or a related equation, okay? And we're going to discuss how it's related. So let's talk about terminology. This is stuff you learned back in 7th grade advanced math. Does anybody remember, raise your hand, what a translation is? Translation. Jacob. Yeah, translating it up or down. So translation means moving it up, moving the line or the equation. But in this case, I'm talking about line because I'm actually going to talk about graphing. So moving the line up or down. So real quick, if I'm talking about translation, just a second. If I'm talking about a translation, this is my line right here. Actually, I'll show it to you here. Does the slope change? No, doesn't change. What changes? Yeah. The position of the line, which is the y-intercept. Okay? Yeah, same orientation. Go ahead, Ethan. What's your question?
I was going to do rotation.
Oh, okay. Hold on. So let's talk about when we talk about a rotation, what's happening to it?
So if it's like this, you change it to like 90 degrees to like this.
Yeah, so it's rotating, right? And when it rotates, what changes? The slope changes, doesn't it? Look, if this is my line and I rotate it, what changes? The slope changes. Okay, so this one is, when we say rotating it, we also, another word for it would be saying turning the line. Does that make sense, guys? Yeah. Now, just for the record, you could also say translation changes. You might want to write this down because this is kind of important. Changes the y-intercept. Rotating the line does what? It changes the slope. The slope. So you can see where I'm going with this. We're going to take a family function and a line, and we're going to see what happens to the slope. That obviously is going to be a rotation. If we move the y-intercept, that's obviously going to be a translation. Are you guys with me on that? Does anybody remember what a reflection is? Go ahead, Ian.
It's taking the line and moving it over an axis.
Yeah, it's moving it over an axis. So if I have this and I move it over an axis, it's taking the opposite. Okay, so it's the opposite. Now, just for the record, if I'm taking it, it's going to the opposite. In this case, when it's here and then I move it here, is the slope going to change?
Yes.
Yeah, it's going to be negative, or it's going to be, yeah. Do you guys see that? So the slope is going to be the opposite. It's going to impact the slope. However, watch right here. Does it impact the y-intercept?
No.
Does it impact the y-intercept?
No.
No, the y-intercept stays the same. Are you guys with me?
Yeah.
All right, so I took this little spot out here. I had something there, and I just filled it in with that. It says, these are all forms of does anybody remember what this word? I'll start right there. Yeah, transformation. You got it. These are all transformations.
I was going to say translate, but
All right, so guys, we're going to actually start with the first one right here. And what we're going to do, yeah, Katrina.
Okay, so you said it like didn't change the wire.
Yeah.
When you
What if it's like
across
this?
the x-axis, wouldn't it?
It'll be
Well,
negative.
I'll show you. I'm talking about for reflection, right?
Yeah.
So watch, I'm going to show you. So if I take this, and this is my line, and then I just reflect it across the x-axis, or I'm sorry, across the y-axis, do you see how the y-intercept is actually the same? Do you see that? Okay, what's changed? Well, this is a negative slope, and now it's a positive slope. See that? A little tricky, but if you look, the y-intercept doesn't change. Now, it could change. We're going to talk about that, okay? Because we could have a different two transformations, okay? We could have a slide and a rotation. So let's check it out. So let's see what we got here. What we're going to do is we're going to look at these different equations, these functions, and we're going to see what happens. We'll see if we can tell which one of these is it. Is it a transformation, rotation, or reflection? So f of x equals x, that's the same as y equals x. That's called the parent function. So what we're going to do is start at 0, 0 for that, because that's like saying y equals 1x plus 0. And then we go up 1 over 1, up 1 over 1, up 1 over 1. Keep going up and over till you have a nice smooth line, and or a whole bunch of, I should say, a whole bunch of slopes. And then I want you to draw a line through that. And then I want you to label it. So we're going to label this one. Arrows off the end, guys. We're going to label this one y equals x. That's our parent function. So now what we're going to do is we're going to take all of these other ones, all these other functions, and we're going to compare it to the parent function. We're going to see what's happening, what's going on. So now this one, g of x, starts out at 1/2 x. Everybody agree with me? Plus what? 0. So start at 0, but now we're going to go up what? Up 1 and over 2. 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 And you can go down 1 and back 2, down 1 and back 2, down 1 and back 2. And go ahead and draw your line in. And there it is right there. Make sure you have arrows off the end. And we're going to label that, hey, instead of writing the equation, you can just write g of x. And you can write f of x for that one, because that's the first one. All right, we're going to do one more and see if you guys can figure this out. Okay, so we're going to start at 0, plus 0 right there. And we're going to go up 3. 1, 2, 3, and over 1. Up 3, 1, 2, 3, and over 1. 1, 2, 3, and over 1. Let me know if I'm going too fast. And then we're going to go down 3, 1, 2, 3, and backwards to the left. Down 3, and backwards to the left, and I'm going to draw my line in. Arrows off the end, and I'm labeling this one h of x, and I'm going to wait for you guys. All right, so here I go. This is my parent function. There it is. And this is my g of x right here. Grab this one. This is my g of x. What's the slope of g of x? Anybody tell me that? What's my slope? 1 over 2. So my slope is 1 over 2. And this one, my slope is what? Up 1 over 1. Everybody agree? Okay, this is my last one that I did right here. If I can get that marker out of there. Okay, this is my last one that I did, which is this guy right here. Now, I could do those other three, but I'm going to see if you guys can get it from here. What's the slope of that one? Yeah, up 3 over 1. So this is a slope of 3 over 1. All right, describe what's happening to the graph compared to the parent function. So looking at the yellow one, sorry, if you need to go get some water, go get some water. Oh, okay. All right, ready? So compare, right now, compare h of x and g of x to f of x. What's happening? What's happening with the slope? Anybody help me out with it? Go ahead, Parker.
Is it going up?
The slope is, use a mathy word. So compare the yellow to the blue, The slope is more inclined. What's the other word? Say it. More steep. Do you see that? Do you right here that h of x is more steep? So write this down. H of x is more steep. Yeah, I don't know. I go back and forth with using that word steeper. I think it's more steep is the proper way of saying it, but steeper? More steep. I mean more steep, not more steeper, just more steep. Well, you guys confused me over there. All right, so h of x is more steep. Do you guys agree?
I
Then,
think it's more I think that's correct though. More steep.
yeah, then f of x. Can you write that down? All right, let's look at g of x. G of x is what? Compared to the parent function f of x is what? Less steep. Yep.
Bless you.
Than f of x. Are you with me? X right there.
C.
Okay, so here's the deal. If we were to finish these and do the other two, what would happen? Well, this slope right here is -1/2. -1/2 means what kind of slope is it going to be? A positive or a negative? Negative. And this one's going to be a -3. So is it going to be negative as well, right?
They're like the same
Okay.
thing, just factoid way.
Right. So if I know, if I look at j of x, can I write j of x down is negative and what? Less steep or more steep? Less steep. Yep, write it down. And then how about k of x? K of x is what? So, but it's also what? Negative, write it down. And what? Less steep or more steep? -3. More steep. That's supposed to have an x by it, by the way. And more steep. Okay, so now look at the overall picture. What's happening to those slopes? Are they translating? Are they rotating? Or are they reflecting? Do you see they're rotating about 0, 0? You guys see that? Okay, now here's the question. Turn that page to the next page.
Will it always start?
It will, in this case. Well, no, I'm sorry. For today, yeah. When it's rotating, yes. Not the others, okay? All right. Yes. Go ahead.
Oh, never mind.
Okay, ready? So the graphs are blank of the graph f of x. They are what? Rotations, yep. A blank is a transformation about a point. A rotation is a transformation about a point. You can think of it as a turn. What is the same and what is different? I'm going to go back. You don't have to. You tell me. What is the same? Say it out loud. Mathy term. Y-intercept. Yep. What's the same as the y-intercept? Everybody agree? And what is different?
Slope.
The slope. So that's what you're writing in. So when you're talking about a rotation, the y-intercepts are the same, but the slopes are different. You guys with me on that? Got it? Okay, so that's what you're going to have to identify on the homework today. When you see like a 1/2 x, you're going to say that it is a rotation. It is less steep. Are you guys with me? Okay. All right, the next one. Oh, wait. Last one on this part is, how can you tell if the line is steeper or less steep? How can you tell if it's steeper or less steep? Ethan?
If it's like more vertical, then it's more steep. If it's less vertical, then it's less steep.
I need it a little more mathy in terms of the numbers. How about if I give you the examples that were given? One of them, I'm going to do y equals, because I can't remember the letters, but y equals 3x versus y equals 1/2 x. 1/2 x was less steep, 3x was more steep.
If the bigger the number, the more steep it is. Because it's like, yeah, because then yeah.
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 So,
Yeah.
ready?
Yeah.
If, yes, go ahead, Katrina.
I have it better than that.
Yeah.
More, how about more succinctly?
That sounds like a challenge.
I know, right?
The higher the numerator is, the steeper it is.
The higher the numerator.
No, because then,
The higher the
no, because it has to be over 1.
No,
Yeah.
the less of the denominator.
It's actually a combination of both of what you're saying.
Some
And
of them.
so ready?
Not the value of the slope. The larger the slope.
The slope, if the slope is greater than 1, then it's going to be steeper. If the slope is less than 1, in between 1 and 0, then it's going to be less steep. You guys got it right there.
Well, not
So here's how you
necessarily
write
less
it.
than 0, 'cause it's
Here's-
actually allowed to be negative.
Here's how you write it. It doesn't matter. Doesn't matter. Because the negative just tells you what?
Goes down.
That it's opposite.
Oh, yeah.
Okay?
Yeah, you said
All right, so here we go. Ready? So if it's steeper, watch. If the slope is greater than 1, then it's steeper.
for like one certain equation or like in general?
That's in general. That's in general. Okay? So ready? It's less steep. If it's, now you got to do a compound inequality with this because it's between 0 and 1 and it is less than or equal to. No, it has to be less than or greater than. And x meaning your slope. Okay, so what do I mean by that? X is less than 0, which is, 0 is less than x. So 0 is less than x, but it's less than 1. In other words, it's between 0 and 1. Are you guys you understand that? So this is between 0 and 1, which means it's a what kind of number? Easier way of saying it?
Cool number.
How about a fraction? Yeah, it's got to be a fraction. Okay. It's a cool way of, yeah, it's a cool number. All right, ready? F of x equals x, that's my parent function. You really don't have to do any work on that. Just start at 0, 0, you go up 1 over 1. You're graphing that. So you're comparing my parent function right here, which is f of x, to the rest of these. What's happening? So g of x, guys, remember there's a 1 in front of the x if it's not given. Now we're not starting at 0, we're starting at what? 3. So go up to 3. 1, 2, 3. And now we're going up 1 over 1, up 1 over 1, up 1 over 1. Keep going. What do you know about those two lines?
Parallelogram.
Parallelogram? Close. How about just parallel? Yeah, I like the word just parallel. Those words. That is g of x right there, guys. That's g of x.
So that's just like
Yeah, it's a translation. You got it. Does that make sense, guys? All right, let's just do one more real quick. So let's do h of x. Where are we starting at? Negative 2. So we go down to negative 2, and we go up 1 over 1, up 1 over 1, up 1 over 1, and draw it in. Label it. They're all parallel. This is h of x. All right, ready? So now we should be able to, am I going too fast? No. All right, so the graphs above are blank and are vertical translations of the parent function. So the graphs are what? Are what? Parallel. Parallel. And are vertical translations. Yep. Of the parent function f of x. A blank translation is a type of transformation that moves every point the same distance in the same direction. You can think of it as a slide. You guys have heard that before, I'm sure. Right? Okay. It is a translation when the blank changes and what stays the same. The y-intercept changes and the slope stays the same. How can you tell if the line slides?
If it looks the same but is like moved.
Yeah, is parallel. Yep, is parallel.
Parallelogram?
Show off.
Okay, but moves up or down, right, guys?
Yeah.
Okay, so is parallel.
Yeah. Yeah, we did it too.
Okay?
Thank you.
All right, flip to the next page. Last one on here. All right, so let's graph these. So f of x equals 2x. And g of x equals negative 2x. So that's 2x plus 0. We don't have a parent function, notice. This is just our first function and our second one. So it starts out at 0. We go up 2 over 1, up 2 over 1, up 2 over 1. Is everybody, Thomas, you can't talk. You got to be writing right now, bud. All right, so everybody should have that. And we can go down 2 and to the left. Down 2 to the left. So there it is right there. And label it, and in this case it's f of x, so we're going to call that f of x right there. Can you guys graph the second one easy?
Yes.
Do you know what's happening?
Yes.
Okay, so I'm going to start here at 0, 0. I'm going to go down 2. Am I going to go to the left or to the right?
Right.
Always go to the, unless you are working right. So we're going to go to the right. Down 2 to the right, down 2 to the right, down 2 to the right. And they are reflections across.
No, I thought they were rotations. Never mind.
They actually, you can say that they're technically it is a rotation, but in this case we're saying it's a reflection because If this is a positive 2 and that's a negative 2, we're saying that the reflections, because they're exactly opposite. Okay? So the graphs above are reflections. This is a transformation across a line that produces a mirror image. You can think of a reflection as a flip over a line. Okay? All right, so your homework, that actually is your prelim. Your homework is to describe the transformations. So you have to describe the transformations. So ready? We're describing what's happening from f of x. In this case, this is our first one. It's not exactly the parent function. It's close to the parent function. But what's happening from f of x to g of x? So I want you to look. Let's make it with the y-intercept. So this would be negative 1x plus 0. Does everybody agree with me?
Yeah.
This would be 1x minus 4. So I'm just, again, adding in a 1, adding in a 1, adding in my y-intercept. Kind of just showing you exactly laying it out there. So this is f of x, and this is g of x. So let's talk about it. So what's happening? Well, my slope is here, and my slopes are what?
The opposite.
The opposite. So what is the opposite? Is it a reflection, a rotation, or a translation?
It is what's the word for it?
It's a reflection. We probably should write that right here, opposites. Write that down so you have it. So then you can kind of look back in your notes. So hold on. So number 1, it is a reflection. Everybody agree? So we're going to write down it's a reflection. Now, what else is it? Well, it started at 0, and it's down 4.
It's also a parallel.
So translation.
Translation.
It's also a translation. So it's
That's what I
translation.
said.
And I need you to write translation. I need you to write translates, is what I want to say. Down. Listen, I need you to write translates down 4. So it is a reflection, comma, and it translates down 4. You guys with me?
Yeah.
All right, let's look at the next one. Again, you can put your 1 in front of it, 1x plus 2, and now this is 2/3 x plus 2. I see that these are the same. So not you guys that just talk, which is Young and Ethan. You guys don't get to talk. Somebody else, go ahead and say it out loud. What do we know about plus 2? What does that represent, plus 2? Go ahead. That's y-intercepts. So the y-intercepts are not changing. So what is not happening? Go ahead, Thomas. It is not doing what? Not translating up or down. Good. Now I look at my slope, and I see that my slope is 1, x here for my f of x, and my g of x is 2/3 x. So, Eisenach, can you tell me what's happening?
Rotation.
It is a rotation. Yep. So this one is a rotation. Now, I want one more thing. Is it getting less steep or more steep? Is g of x getting less steep or more steep? Somebody else. Emily May. More steep? I'm going to look at my notes back here. What do my notes say right here? If it's greater than 1, then it's steeper. If it's between 0 and 1 or a fraction, it's less steep. So now I'm going to ask you again. It is from 1 to 2/3. So what is it? Less steep. Write it down. Are you guys with me on this?
I'm with you.
Okay. So moving along. So these are like double transformations. Okay, things are happening. So transform the graph f of x. Here's my transformation, or here's my original, by reflecting it across the y-axis and translating it up 5 units. So this is what we're doing to it. Okay, so write your original, negative 3x minus 3. And first of all, if I reflect it across the y-axis, it is going to be its opposite. What's going to be the opposite? Back to my notes. What's the opposite right here? Say it.
The x value.
No.
The y-intercept.
No. The slope. Slopes. The slopes are... Yeah, look, opposite slopes. That's okay. It'll be good for me to write that down so you have it. You should write that down. Opposite slopes. So ready? I'm going to go back over here. If this is a negative 3x, what do we make it?
A positive 3x.
Yeah, positive 3x. And then it says translate up 5 units.
So it's adding 5 to negative 2.
Go ahead, Charles. Tell me what I got.
Adding 5 to negative 3, which is 2.
Plus 2. Now, it does not say what to label it, so I need you to just pick a letter g of x equals that. Are you guys following me on that?
Yeah. Good, thank you.
Okay, transform f of x, which equals negative x. What's the same as that? Thank you, negative 1x. So that it has the same steepness, circle it, but in the opposite direction. This should be an easy one. Don't say it out loud. Do it real quick. Sydney, you got it? You got that one? You don't need a calculator for that. Look, that's okay. Ready? I got you. So you're going to take f of x equals negative 1x, and you're going to keep the same steepness, but you're going to put it in the opposite direction. Yeah, 1x, which is actually a parent function, isn't it? That's going to be g of x. Okay? So in other words, these are two the same, right? But one is positive and one is negative. How about that? Do you guys understand?
Yeah.
Okay.
Thank you.
That was a 25-minute